Nick is Research Director for the General Lighthouse Authorities of the UK and Ireland, with responsibilities for radio navigation and communications projects, including e-navigation. He has been closely involved with the international standardisation of DGNSS and AIS, is Vice Chair of the IALA eNav Committee, is a Chartered Engineer and a Fellow of the RIN. His paper this afternoon is on new technology radars and the future of Raycons. Nick, the floor is yours.
Thank you, Chairman. Good afternoon, ladies and gentlemen, and I promise you this is my last appearance. New technology radar. This arises from an IMO resolution approved in 2004, which removed the requirement, in effect from July 2008, for S-band radar to trigger radar beacons. The reason for doing this was to encourage the development of low-power, solid-state, cost-effective radars, which you've just heard about from the previous speaker and we'll probably hear from the next speaker as well. And these use digital signal processing techniques and are generally referred to as NT radar. The General Lighthouse Authorities have conducted 2 trials using an NT radar with a sample of their current Raycon fit. The radar was installed on the Commissioners of Irish Light tender, Granuel. The first trial gave anomalous results. And the second trial was principally carried out to try and resolve those. The purpose as a whole was to determine the performance of S-band Raycons, that's 2.9 to 3.1 gigahertz, with a commercially available NT radar, and the comparison was with a conventional magnetron-based X-band radar. The Raycons were observed as the vessel approached and departed from them up to their maximum operational ranges within the limits of the sea room available. The clarity of response and the ability to identify the codes were recorded at approximately 1 nautical mile intervals on both the NT S-band and the conventional X-band radars. As I said, the second trial was carried out to resolve the anomalies in the first one, which included responses displaced in both azimuth and range from the correct position, which clearly is of some concern. These were the Raycons that were tested, and I've removed the names to protect the guilty, but if anyone wants to submit their guess at the identity of them, there'll be a small prize of a half-pint of kilograms. The first one was on a buoy in Dublin Bay, quite an important buoy at the marks the way into Dublin port, and this was a relatively modern integrated solid-state Raycon. Raycon B was on the Kish Lighthouse, which is a jack-up structure in the approaches to Dublin. The Raycon is of an old design, still in quite widespread use, but no longer in production. Then 2 Raycons were set up on the pier at Wicklow, which was the departure point for the trial, some way south of Dublin. And one of these was a solid-state version of that old design, but again, no longer in production. The other one, Raycon F, was a modern version of a Raycon still in production, and I'll come back to the significance of that. Then Raycon D was on a Lambie, a Codling Lambie, and this is an old version of a Raycon which is still in production. And Raycon E on the Arklow buoy. This is a relatively new design, not generally used by the GLAs, so of particular interest. Raycon F, which is the most interesting point was a modern Raycon lent to us for this trial, and the significant difference is the expectation of a 10 dB improvement in receiver sensitivity. All of these Raycons were frequency agile, dual band X and S, with side lobe suppression enabled and proportional response where applicable. Now, the previous speaker has explained the difference between conventional and new technology radar, but I'll just go through this in summary. The conventional radar is non-coherent, pulsed, high peak power using a magnetron. NT radar is coherent, CW, carrier wave or frequency modulated, with low peak power and solid state. Now, the significant difference here is the high and low peak power, because that's what's needed to trigger the Raycon. That's where the concern lies. This is a summary of the results, and there's a significant difference throughout between the X and S band. The S band maximum range was generally 5 miles or less, whereas the X band was coming in at anything up to 14 miles. However, the exception was Raycon F, which I'll remind you was the new version with a expected 10 dB improvement in receive sensitivity, and that did give us 10 miles on the S band. Show you some of the results. This was Raycon F, which is the modern one, and we did see some anomalies there. That's the correct response there. That's a spurious response out there. That's a quite short range on the 1.5 mile range. So this shows a correct response on Raycon F there. However, it's considerably obscured by land clutter. Again, at the short range. And this shows another spurious response with spoking. Now, we suspect that these spurious responses at short range were possibly due to reflections, because the Raycon was mounted next to the concrete wall on the pier, and at short range you'd expect to get some multipath signals, but I would be welcome any other suggestions from the radar experts present. We then moved out to the 6 mile range here, and this is the other Raycon which was mounted on the pier, which is an older type. We'll see once we get away from the land bit, the response becomes a bit clearer. These are all the S-band responses, and we weren't able to record off the X-band radar, which was an older model. Then we moved down to the Arklow Buoy, which is the one with the newer type of Raycon, and as you can see, out in open water, we're getting a clear response from that. Here at about 2 miles. And this up here is the wind farm on the